Welcome! Hydrocarbons have been known and used for a very long time, for instance by the Chinese, the Greeks and the Romans. Among others, they were used for medical and war purposes. With the Industrial Revolution, however, the need for energy has increased dramatically. Energy was first provided by water and steam, and eventually hydrocarbons. Hydrocarbons have been the game changer of the last century. Never before was energy available to mankind in such amounts and at such low prices. This has made possible an increase in living conditions of large parts of the global population. But what does the future of hydrocarbons look like? There is a general consensus that increasing population and increasing welfare will require an increase in amount of energy throughout the coming decades of the century. This also in the case of improvement of the efficiency of our societies and expanding the use of renewable energy sources. Most analysts estimate that in 2050, something like 50% of the energy budget will have to come from hydrocarbons. This corresponds to an amount twice as large as the one we produce at present. Making such a huge amount of resources available is a major challenge. Is there going to be enough hydrocarbons? In the past, predictions have been made use of the peak theory, which implies that the hydrocarbon production would reach a peak and then decline. The green area in the plot shows the US production of gas until 1960. The red line shows the predicted peak and decline. According to these predictions, gas production at present should be negligible. The reality turned out to be very different. While production initially followed the predictions, around the turn of the century, production started increasing dramatically. The shale gas revolution had started. Technical advances make things possible which were considered as crazy until a few years ago. Think, for instance, at the wells being drilled in very deep waters and across thick layers of salt. In the task of providing energy to the planet, hydrocarbon professionals are required to minimize not only economic, but also the environmental risks that are associated with the exploration and production of hydrocarbons. This is more than ever needed in an age when news travel very fast over the entire globe. Climate change is one of these major risks. Following a variety of studies documenting an increase in CO2 during the last decades, there is now a general consensus that this might cause a rise of global temperatures and other major modifications grouped under the name of climate change. Minimizing the negative effects of climate change and at the same time allowing growth of living standards can only be achieved implementing a variety of measures such as improving efficiency, CO2 sequestration, more renewable energy and many others. Safety is a further major issue. The images of the Macondo disasters are still in everybody's mind and underline the potential dangers associated with petroleum exploration. The report of the Center for Catastrophic Risk Management underlines the weaknesses associated with insufficient regulation and human failures. This is not necessarily the case, and elsewhere the impact of hydrocarbon extraction activities is minimum. Petroleum professionals will have to have very high technical knowledge, high ethical standards, and a strong ability to communicate inside the organization and with the outside world. Having strong and competent public authorities will be of great importance, providing the necessary frame for the resource development and making sure that regulations are consistent and applied. Your task as a future hydrocarbon professional will be a challenging one. Welcome back. Here you see the main components and processes of a hydrocarbon play. The source rock is a rock rich in organic matter which has been heated enough to generate hydrocarbons. The hydrocarbon molecules are squeezed out of the source rock and migrate upward along pathways of permeable rocks and faults. If the migration is prevented by a seal, then hydrocarbons are trapped and will start to accumulate, filling the reservoirs. Hydrocarbons which are not trapped by an appropriate seal will continue their migration and seep at the surface. Producing the oil and gas that eventually ends up in your car or as plastic in your kitchen is a long path characterized by a large number of go-no-go moments involving a multitude of professionals. In the first step, that of exploration, geoscientists will analyze and integrate geological and geophysical data to assess the existence of the basic ingredients of a functioning petroleum play. Is there a producing source rock? Are there porous and permeable layers that can act as conduit and as reservoirs? Are there efficient seals? Are there viable traps? The team will then define the structures most likely to contain hydrocarbons. These are called prospects. To further constrain their geometry, new seismic data is often acquired. This will result in a geologic model which is used to assess the probability that hydrocarbons are present and the volumes of recoverable hydrocarbons. The moment of truth has come, and a well is drilled to test the model. If the well is successful, new data will be acquired, and a detailed reservoir model will be built, and flow simulation will be run to predict the volume of hydrocarbons which can be extracted from the field. A field development plan will be made and infrastructure put in place. Production can start. New wells will be planned, production data will be monitored, and the huge amount of data being produced will be used to constantly update the geological model. When after many years production will start declining, the team will develop plans to stimulate production again with improved oil recovery and enhanced oil recovery tools. In all these stages, your role as geoscientist will be crucial. You need to be an excellent geoscientist, capable of integrating data from different disciplines into a consistent, geological, plausible subsurface model. You must understand the model uncertainties and be open for comments and criticism. You must also be able to communicate with other staff from different disciplines, such as drilling specialists and economists.